Well, hello everyone. Welcome to the Rlogin Developer Workshop given by RIF Identity. My name is Milton Berman, and I am product owner at RIF Identity. I am informatics engineer and have been working in decentralized identity and blockchain for some years. I will also introduce Ilan Olkis, who will do the actual workshop. He's RIF Identity Tech Lead. Those are our Twitter and GitHub handles if you want to communicate with us. So this will be the agenda for today. First, I will talk a little bit about, I will give an intro of what RIF Identity is, what problems we want to solve, what's our vision, and how we use self-sovereign identity models to solve it, and then just a quick intro of the Rlogin that Ilan afterwards will give the workshop about. And afterwards, we will have a QA session. Always you can write questions in the chat box. My first part will just be an intro. It will be just 10 minutes. I will try to go fast so we can get into the code, into the workshop as soon as possible. So to introduce this topic, I would ask everyone this question. So how can we identify ourselves online? So we may think about many things. We may think about authenticating with a Google login or with a Facebook login, or authenticating to a website with a username, a password, or an email and a password. Or if I want to identify with my bank, I may use a physical token or 2FA. There are many ways. Also, there are KYC, where I can put my picture or a selfie or a video recording myself. There are many ways in which we can identify today. There is not a clear and standard way to do it. And that is because of this, because the internet was built without an identity layer. And this was written by Kim Cameron, who was Microsoft Chief Identity Architect in 2005. And he was right, because internet was built in a way that machines could know to which machines they were interacting or communicating with. But you could never know which human was interacting with that machine. And that brought many problems. So nowadays, we are in what we call digital identity 2.0, where digital identity is mainly maintained by the big tech companies or digital services we interact with. We don't have much control nor power with our digital data, with our digital identities. We have to rely, when we sign the terms and conditions with these companies, we have to rely on what they let us do or don't let us do, because in that terms and conditions, almost we concede every right of our digital data to them. So there are some problems, some issues emerged with this digital identity 2.0. For example, some years ago, the Facebook Cambridge Analytica scandal, where they sold our digital data to third parties without our consent. Then they just apologized, and that was that. There was no change there. Also, main data breaches, such as the one with Equifax, where personal identifiable information was hacked and affect millions of people. And as a summary, last year was the record-breaking for record compromises, the year with most data breaches in history. So something has to be done, and we want to help on that. We want to be a part of a change of the digital identity paradigm. We want to move from identity 2.0 to identity 3.0, which is a model, a human-centric model, where we are now in control. We are in the center, and we control our data and share it to whomever we want, whenever we want. It's not as it is today. It will be the other way around. So when I want to interact with companies, digital services, peers, friends, banks, governments, I will be in control of my data, and I will share parts of it whenever I want, and not the other way around. That's where we want to go, and why we are building things. And we will do it with self-sovereign identity models. And so I want to answer this question. So what is self-sovereign identity? It was a concept that was written in a post by Christopher Allen 5 years ago. but it's a continuous work that has been done in the past 20 or 30 years because of this lack of identity layer in internet. And he says that self-sovereign identity is to enhance the ability of digital identity to enable trust while preserving individual privacy. And I remark the word privacy because it's really important in this moment. We may think, and we are right, that we lost our digital privacy, but I think that we shouldn't give it away that easy because it is a human right, and in the physical world, we can have privacy, and why not in the digital world? Yes, okay, our generation may have lost it, but we can work for the future generations to have digital privacy. We have the tools and there is technology to help on that. So the vision for RIF Identity is this list that we want to empower the people to build human-centric identity and reputation, and also enable privacy by default, as I said, to create global identities that are cross-border and cross-platform using self-sovereign identity models. And also, as we work in a blockchain company, we know that blockchain, we think that blockchain will help people to improve their lives, but we need to make it easier. So in our vision, we also have the need to make a better user experience for enable mass adoption in blockchain. So I will go quick, so Ilan can start in a few minutes. This is our macro architecture, what we have in RIF Identity. So we think at the top, we have an application layer where we web and mobile traditional apps, the 2.0 apps, and also the 3.0 ones, the apps and crypto wallets will be able to interact with these new digital identity tools, and they will be able to do it with Rlogin, what we are going to showcase today. And Rlogin will help the developers to interact with these new things that are decentralized identifiers, also blockchain, the Web3 management, and our data that will be in something that is called the Reef Data Vault. We envision this multi-identity model where we are, as I said, we are in the center, a human is in the center, and we'll hold a master private key that will be the RIF Identity account that will derive different decentralized identifiers that could not be linked with each other unless we want to. And also those decentralized identifiers will be tied one-to-one with blockchain accounts. We use, I won't get deep on this, I will just mention it. We use two W3C standards for the decentralized identity standards that are the decentralized identifiers one, the DIDs, and also verifiable credentials. These two are very important for our models, for the SSI models. And I will give in a few seconds, I will explain a typical example on how this SSI role works. There are three typical roles in this case. We are the identity controllers. We are in control, as I said before. And there are issuers. There are entities or persons or companies that will issue a specific verifiable credentials. That is, these verifiable credentials are attestation, digitally signed attestation that cannot be modified and cannot be tampered, and will be issued to the identity controller. So maybe a government, in this example, could issue my national identity card or a driver's license, or maybe a website could issue an email verification, and I will hold all of my verifiable credentials in my mobile app or a web app, and also it could be stored in a cloud to which I can only access. It is totally private. And then when I interact with others, with the verifiers, I can share this data to them. When each piece of data, I don't have to share everything to them, and they can instantly verify it with our technology. So now, the last thing I will mention, I will give an introduction to Rlogin. So I let Ilan to start and go into the code and start the workshop. So I call Rlogin is where Web3 meets SSI. That is because we will use really good tools that have been built for blockchain technology, the Web3, and we will tie it and we will make it to work together seamlessly with self-sovereign identity models and standards. So what is Rlogin? Rlogin is a tool that allows the front-end developer to connect their users with both blockchain functionalities and self-sovereign identity models seamlessly. So in the end, if you're a developer and you integrate Rlogin, you may want to show this kind of pop-up to your user, where your user will select the way they want to authenticate, for example, a Web3 wallet or a wallet, a Connect wallet that is so you can interact from your mobile phone, and we will add others for sure, and then you will have this interaction in a decentralized way with your users. So this is, you may know, if you are in the blockchain world, if you know about Ethereum, RSK, you may know about Web3 model. This is something we use as a dependency in our code, but we are kind of enhancing all the features that Web3 model has. We have additional features so we can tie this SSI layer. So we have full compatibility with Ethereum, but also with RSK. We are compatible with EIP 1193, and also we enable the possibility to be a Web3 provider for developers. But the most interesting thing, the new things that we add, is full compatibility with these W3C DIDs and verifiable credential standards, full compatibility with a DID auth protocol that now Ilan will explain what it is, and also with the data vault, our tiny bag of data that is private, and we will take it everywhere with us. So I finished. I passed only 1 minute, Ilan, of what I promised. So I think now is your moment to go to the workshop. I will pass the mic to you. Well, let's do workshop, Ilan. Let's explain everyone how a developer can use Rlogin.
Thanks. Great introduction. Okay, I'm going to share my screen. Without further ado, we will jump into the workshop directly. So Milton explained excellent everything. Now, what I'm going to do is, first of all, introduce myself. I'm going to introduce what we're going to do in the workshop. And then the idea is to explain how all these concepts that Milton mentioned are taken in the practice. How you build an application that is based on all these concepts that Milton mentioned, that usually it seems like it's very far away, but now with our tools it's very near, and it's pretty easy to use. So the idea will be, I'm going to show some code, like I'm going to try to code what I'm explaining while I'm explaining, and if you guys can follow, you will be able to follow it. If you are not, then this will be recorded, so you will be able to jump back to the presentation and also to the documentation. So let's start. Well, my name is Ilan. I'm tech lead at RIF Identity and also product owner at Reef Name Service. It's domain, it's DNS-like for blockchain addresses. And I've been working in the industry for 3 years here in IOB and in the SSI topics for the last year, or almost 1 year. That's me. If you want to contact me, you can send me an email, Twitter, GitHub, Instagram, LinkedIn, anything, it's okay. And let's go for the schedule. So basically, we are trying to make it pretty fast, like kind of 1 hour. I'm trying to do it even faster than 20 minutes for each section. So first of all, I'm going to explain how to structure your application, and then we are going to do some front end, then a little bit of back end for that front end, and finally we are going to connect to the data vault, that is the place where users can store things cloud-like, but in a self-sovereign way. So basically, they will control their own cloud. And well, at the end, we are going to do questions and answers, but the chat is open, so if you have questions, me or Milton can answer you in the moment. So first of all, we need to think about the structure of our application. and we have two premises, let's say. First of all, that the user has a wallet, so that wallet can be used to represent their identity. So what we are going to do is base all our authentication model in the user's wallet. We know that the user is the only one controlling the wallet, so he will be able to authenticate their self using it. And the other premise is that the user can connect to their data wallet. That will come at the end, but basically what the user will do with the data vault is to store their information and be able to share it with the application. So basically, in a common application, any kind of application, yeah, I can go over there. Okay. Thanks, Solange. So basically, in a common application, we develop a backend where we perform all the business logic, and for sure we need to authenticate users so that users can interact with their own business logic without other users impersonating them. And then our front end is in charge of performing all this in such a way that the user understands that he's authenticating. And basically, I put over here some icons, RSK, Ethereum, and IPFS, because the whole idea of this is that we get the user connected to a blockchain, and the user will be able to do transactions in the blockchain, but will also be able to perform self-sovereign identity operations just with their wallet. So I think I explained all of this, but basically the first thing we're going to do is to connect the user with their wallet. It's just front end. So to connect with the blockchain, we are going to do it directly from the front end. Then we're going to interact with the blockchain a little bit, and then after that we are going to build the backend, and with the backend we are going to install this authentication library so that we can perform a challenge response authentication. And finally, we are going to use also this authentication for the user to also share information in the moment he authenticates, like we would do, I don't know, with Google authentication, that it asks you for the email or for your name or some of your private information. So we're going to show how to do that in a self-sovereign way. So, well, we can just start. So, first of all, as I mentioned recently, we are going to connect to the user's wallet. And for that, we are going to use a specific library. I'm going to share the link over here. Give me 1 second. So for that, we are going to use the Rlogin model. The Rlogin model basically is a tool that integrates Web3 model and adds all the extra functionality that we need for doing the authentication. And then after that, we are going to execute a transaction with the user's wallet. So I'm going to share a little bit of code so that you guys can follow all this code. Sorry, I will also share this link over here. You will be able to follow the presentation over there, and also the code is mostly based on this article that I'm going to share here too, and it's already posted over here. So I'm going to do kind of a follow-up of this repository. So that would help you if you're guys doing this live. If not, for sure, this will be recorded. So you will be able to follow it in the future. So first of all, I created some front end. I used to create React app. So I'm inside a React app. As you can see, there's nothing. There's nothing new over here. Just created a React app. So I'm going to run it, and And as you will see, it will have nothing. So I'm going to start by the cleanup. I'm going to delete everything from the application, and I'm just going to put some stuff over there. We are going to try to copy this screen over here. So I'm going to put an icon, a button that says Connect Wallet. That is imported from Rlogin, as you would do, for example, for a Google authentication button. So I'm going to import that button, and that button will show this nice pop-up where I can choose my wallet. And after that, I'm going to perform a transaction with the user's wallet. So let's go for it. I have over here the application. So first of all, what I need to install in the app is the Rlogin. And the Rlogin is this repository that I shared you over there. I will show it while it installs. It basically, not that one, it's this one. So basically, the idea is that you are able to connect with different providers. We have tested these different providers in RSK and ensure that they are compatible with all the standards we are compatible. And basically, one of these providers is a Wallet Connect. That is very common because you can now let the user connect via a QR code. But you can also use any browser extension like Metamask or Nifty Wallet. And then when you show the pop-up to the user, you are going to get a response that is the provider that you can use, for example, to request any RPC method that is available, like get account or maybe send a transaction. So let's go for it. Oh. Sorry, I need to change my node version. Let's do it again. So basically, I'm going to copy a snippet that I have over here, just for not to be writing everything again and be prone to mistakes. So basically, what I have over here is the Rlogin import. I'm going to paste it over there, and then I'm going to import Wallet Connect so that I can show a little bit how you connect with your mobile phone. So I'm going to copy the Wallet Connect over there too, and the setup is pretty easy, really pretty easy. So basically, what I will do is to copy this object that is over here. So basically, I'm instantiating Rlogin. This will create a DOM object that is the pop-up. And then I have different options. For example, here, cache provider is used for single sign-on. So basically, I can set it to true or false to enable or disable the single sign-on. Then I have different providers like Wallet Connect. But you can add different ones, any that is compatible with Web3 model. This is not yet coming, but finally we also have a supported chains feature that will show you a nice UX when the user is connecting to a wrong network. So that's what I'm going to put the button over here. No functionality yet, I'm just going to run it. Let's see if it goes so good. It should. So I see some chats over here. Let me just read them. Okay, so Lange is asking for putting this bigger. Let me see if I can. Tell me if this is good. Should I go bigger, or this is enough? Oh, even bigger. Okay, what about now? Great, cool. Okay, thanks there for chatting. I love that you are paying attention. You're considering reading the code, so that's fantastic. Well, it's the first time we are running the server for the front end, so it will take a little bit. Okay, now it's done. So it will load over here. We have a button that is doing nothing yet. So we are going to do a pretty fast thing to connect to the wallet. I'm going to show it pretty fast. I'm going to copy a piece of code too. I mean, this can be written pretty fast. It's not something that you will take a lot of time. It's just for preventing any errors. So what I'm doing here, basically, is I'm trying to connect to the provider. Okay. So Rlogin is this object that is over here and enables you to show the pop-up with this function connect. And once I get the connection, I'm going to ask to the wallet what is the account that is exposing. So let me copy those two over here. I also need okay. So basically what I'm doing over here is once I click this button, I'm going to connect to the user's wallet. This will show the pop-up. The user will pick their wallet, and after that, it will show the account. So this is the beautiful pop-up. It was just a matter of 10 minutes, I think, and we can connect to the Web3 directly. So let's, for example, go for MetaMask. Let me first disconnect my MetaMask so that you can see all the whole flow. I'm going to disconnect over here. And now, yeah. So this will ask me to connect to the application. I can pick my account. Let's say I go for the first one, and I can see that I'm connected to the account, and I can have access via code to the user's wallet. I would also be able to connect via Wallet Connect. So basically, let me go for one of the mobile apps. I'm doing our wallet here. Our wallet is one of the RSK wallets. So over here, I have a QR scanner. I'm just going to scan it over there, see if it works. Anyway, we are going to do everything with MetaMask so that it's faster and you can see all the UX that is happening over there. But this is just to show you how it works. So I'm putting here, I'm accepting the connection. Okay. So I hope it works. Today it failed for me. The Wallet Connect bridge was pretty weird today. So I hope it works. Anyway, what you can do always is to run your own Wallet Connect bridge. And that would save you from all the issues that you might have. Let's try once more. Okay, so there I am. I'm connected with my mobile wallet. Basically, you can see over here that I'm connected with this account. And I have control from my phone to that account. So anything that I want to perform with user's wallet will notify me in the phone and just prompt a notification that says, for example, do you want to confirm this transaction? So that would be the UX over there. Now we are going to show everything with MetaMask. So let's reload it now. What I'm going to do over here is I'm just going to add some. I'm going to add some triggers for some transactions. So that I can show you that this is actually connected to the blockchain. So for example, let's put, I have over here a snippet to send a transaction. So let's put it over there. It goes this way. And basically I have here a text input where I can put the address I want to send the money to and a number input. So there I will be able to put how many RSK tokens I will send. And basically this will log the transaction cache that then we are going to show that it's on the testnet explorer. So I need this state stuff. And now we are going to write the transaction function. So basically, what we are going to do is to use this provider that we are storing over here to perform the transaction. We are going to do it via RPC. So let's say we have the send function that is. So this provider.request basically is performing an RPC call. This RPC call basically is one Ethereum call. So you can use, for example, as we were doing before, add account, add send transaction, add sign message, personal sign, any of the RPC available for a Web3 provider will be available here. And we have some parameters. So let's put from, it's the account that I have in the state. The two is the two that will be filled here in the state, and also a value that is also filled here in the state. And after I send it, I will store it over here. So let's put set transaction cache. Let's see if it works. I need to reload manually. There's a weird thing with the state. So basically, when you're using Rlogin in the React, sometimes you need to reload the page for the provider to restart. That's just when you are testing, right? So for example, okay, I'm going to pick another of my accounts. Let's say the secondary. I'm going to copy, and then I paste the two over here. Let's put some value. And great. Basically, this is how it works. When you want to send a transaction, the user is asked, okay, do you want to confirm this transaction? This pop-up over here, I'm not in control of that pop-up from the code, so it's pretty secure and private. Like I cannot trigger this confirm without user action. That's one of the most important security things over here. I just confirm it, and the transaction should be in the Explorer. So let's just search for it. Great. So that's the app in 20 minutes. So if you guys are starting your project, you know that with this you can just bootstrap it in a while. And as we are doing here, I lost here. So as we are doing here, some basic transaction that is sending balance, you can perform anything. You can interact with smart contracts. You can do even batch transactions, like send a lot of transactions. So there are a lot of different operations that you can do. But well, we are going to jump to the next topic, that is the authentication. So basically, over here, we are just standing here, and we have only one part of the application running, that is the front end. But now we want a backend, so we need an authentication layer. And the premise here is one user is one wallet. So basically, we know the user is always in control of their wallet, and we also know that user can sign messages with that wallet. So what we are going to do is we are going to send a random verification code to the user, and the user will sign it and will will just be able to sign it if he's in with his wallet in control in that moment, and also interacting with the app in that moment. If not, he would never know what the random message is. So that's how we bring security to our authentication layer. Let's see some questions. I'm just using MetaMask just because I'm used to use MetaMask, but you can use Nifty. You can use also Liquidity wallet. You can also use the browser wallets that are inside the applications. Like for example, Math Wallet has a browser wallet, and you can connect via that to Rlogin too. That should work fine. Oh, okay. So you're asking why MetaMask is faster. It's not faster. It's just because I need to show my phone in the screen and do all that kind of thing for the presentation. So I'm just doing MetaMask because it's easier for me. But it would work. All of this would work with Wallet Connect, and it's fully tested. Like we have our integration test and everything, so it is working. Okay, thanks, Jesse over there. So yeah, then in the data vault section, I'm going to explain some nice things about security and encryption. But let's just go for the authentication. Up to here, it's pretty exactly the same using any wallet. So basically, for the authentication, as I explained recently, we're going to show a nice verification code. This will be signed, digitally signed, so that proves the user is in control of their wallet in the exact moment we are sending the code, and that also lets user keep that signature private. I mean, this cannot be replied in different applications. So what we are going to see now, it's a backend that just uses a middleware, Express middleware. We are going to install it over here, and we are going to see that we have an authenticated endpoint and one that is not needing any authentication. So let's go for it. For that, I already created over here a backend. I just installed 3 dependencies, Nodemon, just to run it live instead of stopping and restarting the terminal each time. And I just installed Cores and Express that are some basic ones. So let's go to the backend. And I'm going to do okay, not yet because index is not there. So I'm going to create the file. I'm going to run it. And basically what I will do is the common beginning for any Express server. And let's put some cores. Let's use for I don't know 3011. Okay, so we have our app already running. This is server that is running, and what we are going to do now is to install the authentication library over here. So what we are going to do is just the same that we were showing over here. The idea is to build one endpoint that is authenticated and one endpoint that is not. So for the first one, we can just create it over there. Let's do that. I'm going to also copy and paste some snippets I have over here. Hope that is okay. Anyway, anything that you need to stop me, you just send a message and I will try to go into the chat. So, for example, we can have this get method over here. And that should be easy queried from the application. So let's do some Axios. I hope you guys are used to all what I'm showing. This is, I think it's pretty basic stuff. Installing Axios and Express on the backend and all that. So let's just do some queries over here. Not protected is not protected. Okay, so that's it over there. And then I'm going to get the response. So I'm going to store it somewhere. Let's say not protected response. And I get the response, and I'm going to set not protected response date. Okay, so let's do another division over here. I'm going to add some new handles. So this first handle is the not protected. Okay, so this should work, and it's pretty much simple. You know, I'm just building an endpoint, querying that endpoint, and I'm going to start the app over here again. So this basically will just log me something over here. If it goes all good, it should log this not protected over my backend so that you can see that we are both interacting. We still have no authentication layer or anything. We're just building an open endpoint. So that is great. I got the answer over there. And I also have the logo over here. So I know now everything is connected, and I can just jump into putting the authentication layer. So for that, we are going to install one library and two libraries. The first of them, I will share the link over here in the chat, and it's the express.dov. Basically, this is the library we created for backend. And you will see that it's pretty easy to connect the Rlogin to this library. So we made everything kind of easily pluggable so that you don't have to take care of understanding what the backend is answering and everything. You will just see it and you will understand what I say with this. But the front end will handle all the authentication process by its own. So let's just npm install this and that. So basically, we're installing our library, and also we're installing the JWT. Basically, that library is both for creating identities and also for decoding verifiable credentials and also verifying verifiable credentials. So we will do two things. So first of all, we are going to create an identity for our backend. That is very important because in the self-sovereign identity, you interact in this identity layer that Milton mentioned and not in this protocol layer. So basically, we're one layer up, and this is the identity layer that we call. So everything is identified, and the backend will also have an identity, and that's how we can, as users, interact with the backend. So first of all, I'm going to copy another snippet. This is also something that can go wrong if I don't copy paste. So let me just copy the whole identity over here. So basically, I will first import the library over there. Then I'm going to import also the JWT, and then I'm going to to create an identity. So this is for people that were doing self-sovereign identity for some time. This should be pretty something that you have already seen. This basically, I have a secret file where I store my private key. Let's just copy this secret over here. I mean, it's not secret for sure. This is for testing. Don't do this on your own, pasting codes in your pasting private keys in your code. But this is something that you have already done for sure, and it's creating an identity. So basically, we have a private key, we have a public key, and that the way you can associate both is by signing. So basically, with this private key, I can sign messages that can be proved for this public key. And then, well, this challenge secret is something that I'm creating just for making a random chat, this random verification code. And here, my endpoint. This is very important because it will be inside the message. Inside the message I'm going to sign. So if this goes wrong, then the message that I'm signing will also go wrong. So here I was using, yeah, 11, great. And then just in a breeze, you will see that we can just create our authentication library. So let me do this. So basically what we are doing here is importing the setup for the ExpressDL. This will add some endpoints to our application. It adds authenticate method, and it also adds sign up method. Both can have a different business logic. Now, after we connect everything and we go into the data vault part, we are going to see how the business logic works here. But basically what I'm doing is setting up my app. Then if you go to the library and you go to you want to inspect what it's doing in your backend, it is pretty easy to read that code. You will see that it sets such endpoints that are used for the authentication. And then the front end will also interact with those endpoints. And then I'm going to add what we want, that is some protected endpoint. And for sure, we have access to the identifier of the user from the request. So first, I'm going to try to trigger this and get the 401. That is the error code for not authorized. You will see that for sure that's the expected. So let's just copy a new one. And I'm going to trigger protected. So basically what I'm doing here is just doing the same I was doing above, but to the protected one. That's why I'm copy pasting, because it should be pretty similar. So I said protected response, and that should be okay. And this will throw an error. So this error should have the 401 error code. So let's just put it over there and read what it has inside. So let's put the error.message. Okay, unexpected protected word. Let's add to this. Weird. Okay, now it's working. That is something I have never read in my life. That there was a protected word, but okay. So basically, we have our. Let's restart over here. Didn't I trigger this? Sorry for that, guys. Okay, so I'm now running the server again. Let's just see what the server is saying over there. So not protected is working fine, and now this one gets 401. Nothing is happening here, so that is the expected way it should work. Now we need to authenticate. So basically, you will see that this is incredible. This is, I think, is the nicest part of the library. What we are going to do is just add over here the backend URL, and that will make it work. So backend URL, I think that's the name of the setting. Let me check for anything that goes wrong over there. Backend URL, great. So there I will put HTTP localhost 3011. And finally, now we are going to see that it fails again. We are going to see all the flow, it fails again. Then I'm going to show how we finally add the authentication values over here in the protected method, so that we can use the authentication token with the backend. But what we are going to see now is that we are already connected. We are already connected to the backend, and you see over here he's sending me a verification code. This verification code is something I need to sign, and that proves, as I mentioned many times, that proves I'm in control of my wallet, and this message cannot be replied. So I can sign, and I can ensure that the backend is not impersonating me. So if I go for the protected, it will still fail. Now you will see why it fails. Basically, what we have achieved over here is that after the authentication process, we have some authentication tokens over here that we are going to use for future requests. So let's just clear it to see it again. I'm going to connect it just one more time, and you will see I have over here the tokens. So let's just use them in the front end. Basically, what we need to do is to add a header, as most of the authentication libraries do. So what I'm going to put here is some headers, and it's I think it's authentication. Let me just check it out. I'm pretty sure it is that way, but let me just check it up. It's authorization. Sorry, authorization. Then we have the protocol name first, and the token next. So the token, as you saw over there, it is stored in the local storage. So basically, what I'm doing is getting the token and using it for the authorization. It's pretty simple and something you would do with any authentication library. So let's just try it again and see if it works. I hope yes. This should work. So I'm just going to confirm again the identity. Then I sign this message. I got my token over there, so now I can go for the protected, not protected, but also for the protected one. And it's authenticating. You will see over here, I have in my backend the user's account over there, so that was pretty fast. I mean, this is fully secure, and you can use it in your own application if you're designing backend for the app. It's pretty easy to use. And this was thing I think I took like kind of 15 minutes to build the authentication layer over my app. So I think it's one of the greatest features of the Rlogin, and it's great, guys. It's great. This is something that most of the applications need to develop on their own and audit in their own. You just can grab a library that has a security audit and just plug it in your website and go ahead with the important thing that is the business logic. So I mean, this is already solved for you guys. That's great. Okay, now finally, we are going to the datable part. That is the most interesting thing. Oh, I got the 15 minutes. Okay. So basically, what we want to enable in our app is interoperability. So you get a credential from one application, like, I don't know, for example, you get the Ministry of Transport credential, so you store it somewhere, and then when you want to log into the I don't know, to buy a car, then the company will ask you for the driving license, and you can just share what it was issued by the Ministry of Transport without querying again the Ministry of Transport. You can just have that credential that is digitally signed, and you can interoperate among the applications. And this is such way to introduce it to your users. It's something that is brand new. So what we built is I don't mean it's not a proof of concept. It's a working product, but it still needs a lot of usage to strike directly in the point. So what we built here, hope it looks good and you like it, and hope you also have a lot of feedback for it. So basically, what we are going to do is to ask for the user some credentials. As we would do, for example, with Google Authentication. I don't know if you have ever used, but you basically you can fill an array, and in that array you can put, okay, I want the user's email, and I want the access to his YouTube playlists. So the user, when it's shown that that Google pop-up, he will accept or deny over there for sure. And this is kind of the pretty similar flow. And basically, what we are basing on this is that the user has stored all their information in the data vault, and this data vault is a cloud service. Let's say it's a cloud storage service that is centralized in one host now. And basically, what we do is we store just encrypted files. These files are also pinned into the IPFS so that you can have access from any part of the world, and you can access to it whenever you want to, even if we disconnect the server. So that's pretty the idea of the data vault, and the user will encrypt all your information. So that's when privacy comes in. We are not storing anything that the user has never encrypted. So that's the important thing here. We are not in control of any data, and nobody will be, most of the users. So an extra thing of this is that we are also using this as an SDK, so you can access kind of local storage. You will be able to access to the user's data vault after you finish the login, because the user has already access to the data vault. So let's show this pretty fast. What I'm going to do is just to add a line to my code to show the email, to request the email to the user. So I'm here in the backend. Let me see where it is over here. Okay. So basically, what I will do over here is to add one where it's 2 lines. It's just a detail, but I'm going to add a pretty simple thing to start querying the user for verifiable credentials. And what I'm going to do over here is to add these 2 lines. So to explain you, we can ask for credentials. Basically, this should be verified credentials compliant with W3C standard, and we can also require for claims to the user. So user can say, okay, my name is Ilan, and have no verification for that. It's just something I'm claiming for my own. This time I'm not going to ask for any claims, but we could. We could put name over here, or I don't know, dog's name. You can put any claim you want to request to the user. So Okay, it just restarted. Let's go back to the app, and we are going to see that with that single line that I put over there, the flow will completely change, and it's already plugged into the front end. I mean, from the front end, I did any changes. What you can see here is that this pop-up Rlogin is understanding what the backend is asking for and showing it. I could show this that car color. I don't know. I can ask for anything that I need from the user. The user is the one who is going to share it. So that's kind of the idea of this part of what you're requesting to the user. I'm just going for the email one, and I'm going to show you how does this work with the data vault. Basically, there's an SDK over there, and I'm going to share the link too for the data vault SDK. That link that I showed you over there has a lot of modules. We have the service open source, so you can check everything. All this suite is open source, I mean. So basically, what I will do over here is to access my data vault. I just query the data vault. What I'm doing here is accessing the service. So once I access the service, I'm asking this service, okay, I want to recover my email credentials, so give me please the information that I need. And what you see over here is what Jesse mentioned before, that is something regarding security. So you were asking about differences between Nifty and Metamask. Basically, Metamask is now supporting asymmetric encryption. So what we can do is to decrypt all the information in the wallet first. You will see there's a JWT over here that is the credential. So let's say I go to here to jwt.io, that is standard one. So I can first check what I'm going to share with the application before sharing it. That's a very important privacy step over there. So let's say I accept, no, and I already verified that this is the data I want to share. So I basically decrypt it, and the application will understand that I'm sharing a verified credential with it. And they can just confirm it, and it should log in okay. I hope so. Let's see. Okay, I can go for the protected one, and it's working. Great. So now what I will show you here in the back end, tiny detail that we have over here, is that it seems like it is doing nothing, but basically what we can do is to install a middleware into the middleware, let's say, and this thing will let you access all what the user is sharing. So let's say I want to add some business logic to the sign up. So basically, I get here the payload that the user is signing in their front end. And okay, let's say I want to decode the credential I'm getting. So I just want to decode it. I'm not going to verify it and all that. You can just add the business logic you want over here for the sign up. It can be any business logic you want. So let's. I have here. I will decode it. So let's put decode JWT of, and here it's kind of weird. This is SD stands for selective disclosure. Basically, the user chooses what he's going to disclose. So we call it a selective disclosure, just because you are selecting the information you want to share instead of sharing what the application wants you to share. And from there, we can find claims like this, or we can also find credentials like that. And let's grab the email one. So I'm going to decode it, and I'm going to log it, no? Email credential decoded. And then I need to assert that the user can log in. So I'm just going to return true. So to let I'm just saying, okay, this user can log in, but here I could say, I don't know, if email credential decoded is in my database, then user cannot log in, so I return true, false, no? And that works pretty fine. It's just for you to add any business logic to your sign up. And let's see what happens now when I try to log in again. So basically, let's just reload over here, connect to wallet. Again, I'm going for the email credential. I'm going to download it from my data vault. Now I'm going to show you how to access the data vault like manually in other way. But I can just, I'm just assuming I got this credential from somewhere. I mean, now I'm going to show you how you actually get this credential. So I can now confirm my identity. Let's reload. So, I'm getting authentication error. That's weird. Let me just copy the snippet I have over here. Let's see if I can make it work with my snippet. So I got it like this: sign up business logic, and then I had a function over here that is this function, and the code JWT. Okay, and it's doing basically the same. I'm just copy pasting, so maybe I got some error typing. I hope it works now. So let's see. Let's try again. It would be a pity if it does not work live. I mean, I've tested this 1 hour ago, so I don't know what's happening. You know, live demos are crazy. So let's just try again. Basically, what I'm doing now, it's all the verification again. I'm doing the authentication, and I'm sharing my credentials over there. So I'm going to say, oh, it worked now. It seems I made any typo or something. So here you will see what I'm receiving here in the business logic. Is basically, I have this payload of the email. This is the credential the user is sharing with me. And then I have also, after I decode the JWT, I get the subject, and it says that this is my mail address. So just to show you a little bit more of things, we are also working on a standard that is about credential subjects. So basically, what we need for interoperability is for everybody to read this credential subject as an email. I mean, if I'm sharing an email credential, then application should be able to read it and understand the semantic of all what's inside the credential. And for that, we are building this repository that is verified credential JSON schemas. Basically, there we are just specifying different credentials, and we started with the email because it's the most common one. But then this needs to increase over time. We just have one model, one just JSON schema, but anything that you need for your application to interoperate with other, this is the place that we want to feed and get it better. I'm going to share the link too. So, okay, that's a tiny announcement over there. And finally, what I mentioned you before, I'm just going to do one more thing in the front end. This will be it for the workshop. So I think it will take me 2 minutes. Sorry if I took a lot of time. I think I did well with the time, and you are not bored. I hope so. So what we are going to do for the last step is, as you can see over here, I will show you some things. As you can see over here, I'm connecting to the data vault. So let's just do it again, just to show you the interesting part. Let me clear all the application state and everything so that you can see it from scratch, no? So basically, the idea over here is that I connect to my data vault. So when I click over here, it is performing some authentication. You will see that it's pretty similar to what we showed in the DDoS, in the middleware explanation. So actually, it is using that middleware in production. I mean, it works. You can see over here, it is working. And you can also set your own custom message and some pretty cool things. So what we are doing here is to set a nice message, just that, but it's the same library. And what we are doing here is we are connecting to the server, so that needs authentication, and then we are decrypting some things. Okay, that's just a detail, but this authentication that we have just performed is still alive. So what you are going to see now, I mean, now I have this working, but I can also connect to the user's data vault from the code. So here is the pretty cool stuff. I hope you guys like it. So let's just do another division. And what I'm going to do is, first, what I will receive over here is not just a provider, it's also the data vault. I think it's written that way. Let me check it up. Yeah, it's that way. And this is another object. This object lets me interact with the user's data vault. So let's just state it. Data vault and set data vault. And once I receive it, I can then interact with the user's information. So let's say I want to, okay, so what I created, I already uploaded some information to my data vault so that you can see I'm downloading it. So let's just get some info from the data vault. So what we are going to do over here, it's basically it's similar, pretty similar to what's local storage. So there's basically you can get information via keys. So what I will do over here is data vault dot get. Then okay, I have to use my identity here. Let's put it's account, no? Yeah, account, and then for the key, I'm going to use one that I already used, but you will see that I can choose another one. So I think it was workshop sample, and then I can get a file, right? So what I will store it somewhere. Let's put content over here, content, and set content. It's an object, and now you will see what the object has. So let's just set content, and over here we're going to put some div buttons. I want to get some info, great. Get some info, and now we are going to put the file. So content is content dot it's content dot content. Okay, sorry, I'm missing something. This is an array. So basically, what you can store over here in workshop sample is a lot different contents. I'm going to show what I did store over there. So what I will do over here is just if content, then I'm going to map each of the things. So let's put P needs a key. So let's put the ID. So each of the content has an ID, and this the Ipfs cache. And let's put over here the ID. So basically, the ID is an Ipfs cache. I don't know you guys if you know what Ipfs is. It's basically a distributed network for storing files. It's pretty insecure if you store the things unencrypted, but you will see that it's everything it's encrypted over there, and it's encrypted by the user. So basically, what you will get over here is a hash that is encrypted and should be encrypted by the user wallet, but the SDK will decrypt it for us. So hope this works too. I forgot the arrow. Okay, now it should go fine. Great. So I'm going to connect once again. Sorry for this whole process. I mean, there should be a way to make it pretty fast. But I'm just confirming the identity again. As you can see, I'm interacting with the backend as we did before. But I can also get some info from the data vault. So what you see over here, it's trying to decrypt this data. So I stored some stuff. One is sample 1, so let's decrypt it. And sample 2, okay, let's just decrypt it. And you will see over here, this is the content that is stored there in my data vault. So then I can also upload some content. Let me just do that pretty fast if you want. So it's okay, I'm just going to copy it so that I don't take too much time. But let me see if it's over here. So content, okay, it's this one. So basically, I have here set new content. I'm going to store something in that key. So let's just put it new content, set new content, and over here it's just one API call. It's pretty fast as the other one. I mean, this get some info was just one line of code, and store some info will be another line of code too. I mean, add content. I'm using the same key, so then I can get it. Then I'm also storing what I said in the input. So let's just try it pretty fast. Okay, I think I will need to reload just in case. I will do it pretty fast. So, okay, I got my access. Okay. Was too fast, maybe. Okay. Let me see if I didn't make any mistake over there. I hope we can check what's happening over there. Reproduce this error. I don't like it at all. Something went wrong. Okay, now I'm authenticated. Great. So I can, as before, I can get that info. I can decrypt it, and then I can also add some info. I would put sample 3. I will add that content. So basically, this is doing asymmetric encryption. So it will request me for a public key. I will just provide it to the site. And then if I get the info again, it should let me decrypt the 3 of them, 1, 2, and 3, and it's over there. So great. That's the demo, the whole demo. That's the whole product we've been building the last I think 6 months. We built everything mostly from scratch, let's say. So I'm very glad it works, and we can demo it, and we can, or even code it live, since it's so easy to code that we can do it live. That's the matter of this, that you can jump into SSI pretty fast, guys. And just for the end of all of this, we have an application. We have our own application that is the Identity Manager. So basically, in the Identity Manager, you will be able to see all the information that you are doing over here. I mean, the users can do things with their identity, not just for the login. So basically, here's my data vault summary. I can see some DeFi assets over there. If you're using Ethereum, I don't know, you will see a list of a lot of tokens. Same for RSK mainnet. This is just an application that is just starting, but the most cool thing is here the data vault. So basically, I can download the content that was stored over there that I did mention before. So here you will see I have all the content, and cool, very cool. I can also download my credentials, so I can decrypt it. Here you will see again my credential, the one that I shared. It is using our standard for credential schemas. We can even show the raw, I mean the JWT, and also perform a presentation. This is something I've never seen in SSI World 2. Doing a presentation from the web browser, something I never seen. Really, I never seen. And this is also opening a new window. Okay, so this is also something we built on our own, and it's a JWT verifier, but this is not the same as JWT.io. This is also querying for the identity, and again, this is open source. It's ready for you to use. So here's the credential. It looks like a credential. That's really nice. So well, guys, that's pretty much it. I think it was a lot. So you guys go back in the video if you need to. I'm just going to, well, I don't want to waste much more time, but basically this is what we showed. For the authentication, we are using Express.out for the data vault, the Reef data vault, and for the user's wallet, we're using the Rlogin. So you can go back in the slides and see how we built our model just based on the tools we are working on, and this was the whole objective of our project. So it's time now for you to ask any questions that you have. I'm jumping into the chat.
It was awesome, Ilan.
Thanks.
Great. Great. And I was following the people, and the majority stayed the whole time, so that's really good.
Great. Also. Yeah, I went pretty fast. You guys, I hope. I know there are some Spanish speakers. So I'm pretty Latino, so I speak Latin Spanish, Latin English. So hope you could understand everything. Any mistake that we did or something, I mean, you can just contact us and tell us. If you find something that you want to improve on our model, anything that we're open for your emails and messages. I see here some messages in the chat. Thanks, Sergio. Off topic, Reef Marketplace doesn't recognize my Nifty wallet. Okay, that's really off topic.
Yeah, they have to implement Rlogin before.
Yeah, so they didn't integrate us yet. They are just on that. So I hope that when they integrate Rlogin, you just can go back with your Nifty. Yeah, so there Solange posted the open Slack for RSK. There you will find channels for all our products. There's also a general channel and developer channel, so you can just put your question over there. Somebody will answer more wisely, I hope.
I would like to answer Sergio Fison. He asked in Spanish if you can use this to identify physical persons in close organizations for voting or similar. Of course. And you, as we built it, you have many flavors of it. You can do it for close organization, a really close environment with the typical way of doing it. And you can do it for open environments. And you can also choose the degree of anonymity you want. So if you want to do public voting, this is perfect. You can show it to everything to everyone, and you authenticate with your DID. And also, if you want to do private voting, you can, because we are always privacy by default. And the identification also, you can identify just authenticating with your private key, or you could add other layers. You could add maybe a verifier credential with your national ID card or with your photographs. But the important here is that, or what we try to explain, is that it's important that that info, personal info, is on the people's cloud, in the people's data vault, and they only share it in specific moments when needed. So you can have more privacy. It is not magical that you will have privacy in everything. There always can be a data leak, but if you develop it right, thinking about privacy, you can do it perfect. You can link a national identification card with your account without the other types of accounts knowing everything about you.
Great. So just to complete Milton's answer, basically, we have over here a tool that verifies emails and emits a verified credential for that email. So what you see, that is my verified credential over there. I can just verify it over here. And this could work also for any kind of identity. I mean, if you have a national ID card and you want to do, I don't know, a manual verification and issue credentials, you can just get a picture of the national ID card. Here in Argentina, we have an application that is called Renaper. So you can even use that to verify that the credential is good. But I will show you just a little bit of this flow that it explains mostly everything. I mean, this has an own backend. So what I'm going to do is to verify that I have received this via email. The email is over here in my other screen. So I will send it. I will send it back to the backend, and he will send me a credential. And this credential is the one that we were showing before. So there, if you can issue anything and then interoperate from the Rlogin with anything. If you then store it instead of, I don't know, email credential, you put a national ID card, then the person would be able to vote using that credential.
Yeah, and about this one of the email, it's interesting because you can have your email verification issued by one entity of trust, maybe a social network or a website that anyone trusts. And then you can bring this verified credential to any other website. So those other websites will just trust on this first website that issued the credential, and you don't have to send an email to the guy to put a code, and then to verify everything once and again. So those websites will spend much money sending those emails, for example. You avoid that. So you also can save money while integrating this type of solutions.
Yeah, that's what we call data portability. You can port your data to anywhere. It's already digitalized. Okay, thanks, Amelia. Thanks, Reef. Thanks, Lucas. Thanks, Sergio. Thanks, everybody. Any more questions? If you have any other questions, you can just ask us. Anyway, I leave here. I will leave again the presentation with all the links. This presentation will not move from here. So there you have all the links I already shared in the chat. And maybe I added even more links that I shared that were not expected to be shared. Those are all the repos. You will find the documentation. Documentation is really good. I really like our team's documentation. I mean, you can just copy and paste some things before you start getting in depth. So you will find it all over there. Then, if you need to contact us, here are our handles. and our emails. So you can just contact us via email, Twitter, anything. On my case, anything would work. In Milton's case, I think too. So thanks.
Thanks everyone to stay the whole workshop, and thanks to the people that will watch via YouTube. It was great, Ilan.
Thanks, Milton.
Okay, bye bye.